Hi guys, welcome to this explainer video of data analysis in Python. We'll use tools like Pandas, Seaborn, NumPy, other data analytics and prediction tools. This tutorial is fairly meant for beginners and intermediates and anyone who wishes to refresh his or her knowledge in data analysis. We'll cover general workflow as displayed on your screen at the moment that is required for day-to-day analysis. I'm not going to waste your time. I'll try as much as possible to be brief. And while at that, I'll try to explain the meaning of all the codes and also interpret the visualization that may come up. In order not to waste too much time, this is what we're going to cover displayed on the screen at the moment. You can refer to it anytime during the video, but essentially this is what we're going to cover today. So if you're ready, let's dive in. Yeah, so here I have my command prompt open. I've also navigated to the part where my data set is. This is the Excel file that contains all the data that we intend to use. Let's have a quick look. Yes, so this is the Excel file. You can see the columns and the rows. This is actually not important at the moment, so I'm just going to minimize it. I'll bring up my work environment, which is JupyterLab. Yeah, so as you can see, the JupyterLab is launched. It's not so different from Jupyter Notebook for those of us who are familiar with Jupyter Notebook. Like I said before, you can run all the code in Visual Studio Code as well. So I'm going to open a new kernel. As you can see right here, my data set is already in the same folder as the environment where I'm working. So as stated in the workflow, the first thing we need to do is to import some libraries. We're importing Pandas as PD, then NumPy as MP. I'll execute that. Then the next thing is to bring in the data sets in Excel as a data frame here. So what this is doing is that Pandas should read the CSV file. I'll give it the name of the CSV file. Then the next thing I want to do is to actually see the first 10 rows in the Excel file. That's in my data frame now. So my data frame is df_diabetes. I'll execute it. Shows you exactly what you've seen in the last when I opened the Excel file. So after ensuring that we're able to view the columns and row from the data frame, which is coming from the Excel data original file, the first thing we may want to do is to check whether this file contains some null values. If there are null items in the value, and you do that with your data frame, if it's null, if there's any column that is null there, yeah, it shows that there's no column at all that is null. You can improve this just in case you feel there are, or it shows there are some true values here. You can put some to know how much they are. And as you can see from here, it's 0, 0, 0, 0 for all the columns. So that's fine. It looks very fine. The next thing is to check the shape of the data to know the number of rows and columns that are contained in your data frame. So you do that, your data frame name dot shape, you execute it. So what it's telling us here is that we have 100,000 rows in the file, and you have 9 columns. So after confirming that we don't have null values in our data, as indicated 000 here, and false in the first place when we executed these values of false, shows that these columns don't have any null value. The next thing we might want to do is to check the information of the data frame. So df underscore diabetes, don't forget df underscore diabetes is the name of our data frame. So we use .info. When you execute that, it shows you the number of columns that are present, the number of rows, the number of columns, then the data types. So gender is a string object data type, age you have float 64, and the others are integers. So these are important information that you can get from .info. Then you may want to quickly know the statistical representation of the data in your file. So we use .describe for that. .describe gives you a quick look at the standard deviation for each column, the mean, the total number of counts for each column. 25% of the data have these, 50% have this, 75. What's the minimum value for each column? This is the minimum value, 0.08 for each. The minimum value for hypertension is 0.0. So .describe just gives you that statistical analysis of the data you are viewing. Then let's pick a specific column. Let's pick this H column. I want to know the unique values in each column. So this shows us the unique values in the column. Unique values are numbers that don't repeat themselves. They are just represented once. What else can you do with examining your data? Let's check the value counts in each column. So this dot value counts gives you a representation of data, unique value counts in the each column. Yeah, so that's done. What else can we do? I would like to look at my original data sets, df underscore diabetes. As you can see, I have some columns here that are strings, and I have others that are integers or floats. This is a string column, for instance. I would like to create another data frame that contains only columns with numbers, no string. And it's very easy to do. All I need to do is create a new variable called float_calls underscore diabetes. This part, you can name it anything you want. So it's picking the data from your original data frame, which is df underscore diabetes. And what we are telling it to do now is that, select only these columns from df underscore diabetes. And once you've done that, put all these columns into floats calls diabetes, and we will see that. So now let's see what's there in floats calls underscore diabetes. Let's say dot head, as we've used before. Let's use 5, so it shows us the first 5 rows of calls underscore diabetes. So essentially it's the same data, but some columns have been removed from the original data sets. So that's about how to uh, transform the original data sets into a new set that is of interest to you. You just have to show your environment the columns you need, and it's just straightforward. We can perform the same operation as we've done before. Let's say dot describe in this case for this same data frame as well. Yeah, so here we've used dot value counts, but we manually provided just one column for it. Let's try to do something interesting. Let's create a function in JupyterLab that automatically takes multiple columns and then outputs the results for us. So in this case, we call our function name define unique values. It takes data frame, then it takes some column list. It may be more than one. And for each name in the column list, it will print the column, okay, then print the unique values and enter a new line. So yeah, let's do another one similar to the first that we just completed, but in this case, this one is getting the value counts. Don't forget, the first function is getting the dot unique, and this one is getting the value counts. The usefulness of this method is going to be transparent to you almost immediately. So your function gets the data frame and the names of the columns. Get unique values, which is this, from this data frame df underscore diabetes, and it will get you the unique values for all these columns. Let's say we execute it, and you can see, just like you told it to do, for every column in the column list, these are the column lists, prints column string, then the column. So which is, this is the string, this is the column name, then it's giving you the unique values in the specified column. In this case, you have multiple columns. So unlike the first one we did, where we just used dot unique here for age, you are doing it for several columns. So that's the beauty of that. Let's do the second one for value counts, and we are going to, just like we did in the first one, we are going to impute as many columns as possible. So get value counts, the data frame name, in this case the data frame we created here to contain only floats and integers. Then we specify all the columns that are there, and let's see, so it's giving us the unique value counts for all the columns, and this is just the beauty of programming. Yeah, let's try to do something different now. When we executed a query to tell us the unique values in gender column, it told us the unique values are either female, male, or other. Now we want to filter this gender column to show us every other column that has female and male, but not other. Okay, and how do we do that? It's quite easy. Let's create another data frame that will contain only male and female as the variable for gender. So we create a new data frame called filter underscore diabetes. You use the original data frame df underscore diabetes, the data frame df underscore diabetes, but gender column, give me everything that is not order. That's what the statement is saying, and that's it. So how do we know that we are right? Let's quickly examine filtered database data frame. You will see that it's giving you, from the first 10 columns, it's giving you everything that is this. Let's do the value counts like we've done for other data frames before. And then it gives you these results. How about the shapes? Let's compare the number of rows in this one compared to the original data frame. Yeah, it still has 9 columns, but instead of the 100,000 rows that are contained in the original df_diabetes, here you have just less than that. Another thing we might want to do is to copy a data frame. Maybe we don't want to mutilate or destroy or modify the original data frame. So how do we do that? You just use .copy. You state the data frame that you want to copy, in this case filtered_diabetes. So my data frame name here is going to be copied _diabetes_df. You can give it any name you want, and it has copied it. If you do .shape of this guy, it should give you exact as you have in the filtered_database. And yeah, so do you see this? And compared to this, they are the same. Alright, so the next thing we want to do is to plot a pie of our data to see actually how they look in a graphical format. And to do that, the first thing we'll have to do is to import MATPLOTLIB. We're importing it as PLT. Then I'll give it some values and I'll try to interpret. So we're telling it MATPLOTLIB to plot a pie chart for us. It should use copy_diabetes data frame, the gender column. So it's going to use the value counts in the gender column. The label is also going to be the unique value counts in gender column of copy_diabetes data frame. And this auto PCT is telling it how exactly to format the percentages. So we have to add a title. Then we'll also ask it to show us the plots. Let's add a title. So the title of our pie is going to be pie charts of gender. Then the last line is saying show us the plots, show us whatever you have plotted. So this is a good example. It's just showing you in a matter of seconds that there are 58.6 females and only 41.4 male represented in the data sets that we're looking at. Another example, let's plot a pie of the diabetes column. Okay, same way we've done the first. Tell it, and we have 91.5% against 8.5 here. If you do a value count of diabetes column in the data frame that we are using, the value should correspond. You see the people without diabetes represented as 0, they are 91,482, and those with diabetes are 8,500. Yeah, so instead of plotting a column of your data frame H like this, something creative that we can also do is to plot multiple columns on a single row or on multiple rows, depending on what you want to do. In this example, we are saying there are subplots. You should use just one row, but 3 columns. So we are presenting 3 columns to it. And the first column is represented by this index of 0, the second index of 1, and the third one is index of 2. So this is similar to what we have done before, the label, the column specification, and all that. And we are setting the title. Finally, we say plt.show to show us the pies. So as you can see here, you have 3 pie charts on a single row. As we move on, I'll do examples of plotting maybe histogram on two rows and multiple columns as well. So let's bring in Seaborn in order to plot some histogram. Import Seaborn as SNS. Then we give it a similar query like we did for pie charts. I'll just dump the code here and try to interpret it. So it's going to make us a figure, and here it's creating 2 rows and 2 columns. The figure size is going to be 10 inches wide and 8 inches of height, similar to what we have here. And then the type of charts that we want is histogram, and it should use the copy underscore diabetes data frame. In this first plot, it should use age, and the title should be histogram of age. It's going to have 10 bins. 10 bins means that categorize all the values you have in each column into 10 spaces, and I'll show you when the plot makes. Then the axis, so in the first column where you have 0, this is going to be the first plot. On the same column, on the same row rather, 0 row, that's the first row. This is going to be the second plot, so the index is 1. This is indicating the second row, and this is going to be the first plot. This is second row, and this is going to be the second plot. Finally, we are telling it to show us the plot. So it's going to take some seconds before it delivers the plots. So this is where the bin plays a huge role. You can see the histogram of age. You ask it to give you 10 bins, so it has formatted all the graphical interface into 10 separate values, up to 80. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. So it shows us the distribution of the variables against the value counts. And from this chart, you can tell that the sample data being used has the maximum age between 50 and 55. 50 and 55, yeah. So this is a histogram plot. Now we want to see scattered plots in order to view relationship between the variables that we are talking about. Here, when you are doing scatter plots, you have to specify the x and the y. In this case, we want to correlate age and diabetes. On the second plot, we want to correlate BMI and diabetes. And then you have lastly the glucose level and diabetes. You want to view graphically how they interrelate, whether there's a relationship among these variables. Again, we are using the same data frame that we use for the histogram plots. Okay, so it's kind of confusing for first timers to be able to interpret correctly what's scatter plots, what's meaning you can derive from it. So in this first plot, uh, in the Excel data that we're using, those without diabetes are labeled as 0. Those with diabetes are labeled as 1. So it's either you are 0 or you are 1. Now you can see from here, regardless of your age, which is on the x-axis, 0 to 80 years old, you have people that are non-diabetic. And then also from the second classification, 0 to 80, you also have some people that are diabetic. So it's not, what this guy is showing us is that it's not a function of your age. It doesn't really matter. Where the difference comes in is when you check this variable against diabetes. You can see that those with this level, HbA1c level, you have a few of them that are non-diabetic between 0 and 6.5. But those that are diabetic have values between 6 and above. So these directly correlate. The same thing with the blood glucose level. So this is the interpretation of scatter plots. I will see further examples on scatter plots when you want to plot not just two variables. Maybe you want to use hue as well. Yeah, further to that, let's see an example of how we can correlate three variables within the same data set using hue. So this makes the difference between what we have done before and now. So it's going to colorize the value you've used on the x-axis versus the y-axis, and you see how it interrelates with gender. Again, we are plotting on two columns, two rows with the same height and weight as before. Let's see how it looks. Finally, it's here. So the male and female is represented here. So for the first column, we say you should use gender. So within this distribution, you have this orange value showing you that these are male within this class, and for the upper class as well. So now let's correlate our data. It's important that when you want to use the corr function, you ensure that your data sets don't have text in them in order for it to be able to appropriately correlate the data. So we are going to correlate our data sets, then we're going to use heatmap to interpret visually how this correlation happens. So we've done selection of some columns before when we use this floats underscore calls underscore created this data frame. So you just add .corr to it, and it's going to now output the variables into this new data set. So let's check the data inside here to see the correlation. Now it has correlated. Of course, when you correlate a variable against itself, it will give you 1. So the strength of correlation, the higher the value, the more influence the variable has on another. Like BMI is 0.3, it is 1 against itself. It is almost negligible when you compare with these. So essentially the .corr functions, the higher the value, the more influence that you are going to get. If we like, we can create a new data frame afresh, and let's see how to do that. So here we are telling this data frame to drop some columns in df underscore database. What are the columns to drop? It should drop gender, it should drop smoking history, which if you look at the, yeah, if you look at these are texts, and the smoking history is also text. So let's just drop those columns to give us just the columns that we need. Now if you look at the data frame that you've created, they are float numbers and integers, so that's okay for us. Now let's run a correlation on the data frame that we've created. So we'll create another variable called corr of this data frame, and we are simply just telling it to correlate. It's as simple as that. Then look at what you have correlated, and then you have these essentially. So if you look at these values that you have here, the HbA1c level is at 0.4 against diabetes. Our glucose level is also 0.4. If you check the other values you have, they are far less than that. So among these variables, it's showing you at a glance that the diabetic possibility is highly correlated to these two values as compared to others, and it's even more visible when you do a heat map. Let's show the heat map of this correlation. So we'll use SNS to plot a heat map, and this is the data frame we created. We're plotting a heat map of it. Yeah, so it shows you a diabetes against hypertension. How many hypertensive patients have diabetes? What's the influence? 0.2. Heart diseases is almost not related, but if you look at the glucose level, is 0.4. That is weighty for diabetes. And if you look at HbA1c level too, it shows you the same thing. Yeah, right now, so let's try to see how we can do some classification within our data. Let's see how we can group the data. So by using a group by function, we should be able to do some meaningful things. So I'm creating a new data frame called gender underscore group. I'm using my original database, my original data frame, and I'm asking it to group by gender. So it's going to group all the rows in the data set by gender. Let me see what it has done. Okay, so it's giving me the total number of female, the total number of male, and those classified as order. So I can see the amount of data belonging to a particular set that I'm interested in. We can do something bigger than that. We can tell it to create a pivot using two variables. So in this case, if I modify this variable gender underscore group, I'm using two columns now. It should group using gender and also diabetes. Then it's going to make a size of that. Then it's going to unstack the data, which means create a pivot like data for me. So the row of the pivot is going to be gender, and the column, whether somebody is diabetic or not, is going to be is going to be the column. Yeah, let's see. I hope I explained it well. So if I execute this gender underscore group again, you can see now the rows is female, male, order. How many females are diabetic? 54,000. How many females are diabetic? 4,461. How many females are non-diabetic? 54,000 plus. The same thing applies to other group. So we can repeat this for multiple variables. Let's just load it up. I'm doing this for gender and diabetes. I'll remove this first line. I'll do for hypertension and diabetes. I'll do for heart disease and diabetes, smoking history and diabetes, and we'll see how it looks. Once I've grouped the data, they'll just be exactly like we've seen above here. What I would like to do is to correlate the data to see if I can derive some knowledge from it. I don't need to explain this again. I'm just asking it to plot these variables, and it should give me a bar chart. Then set the titles, and finally just show me what you have plotted. So what can we derive from here? The number of non-diabetic female are far more than the ones that are diabetic. The number of male, even though not as much as the female that are non-diabetic, are also far more than the males that are diabetic. When you come here, you see the classification. So it has classified for you smoking history, those that don't have any info, those that are current smoker. Those that are current smoker, the ones that are non-diabetic are far more than the ones that are diabetic. Of course, the value in orange one is they are the diabetic people. What again can we do when we have data? We can try to label the data. Try to label columns. So group them, classify them per the way we feel best to look at them. So in this session, let's think of a way. How about we think to create an additional column? We'll call it age category. That is going to label from the age column. Is going to look at the age column. Any value it sees there that is less than 30, you should classify the person as young. If he or she is more than 30 but not older than 60, classify the person as middle age. If the person is older than 60, classify the person as old. And you do that for other variables as well. So let's put that in a language that's Python understands. How do we present it? So I just give you this. So for labeling and substituting data, you need two variables actually. You need the bins and you need the labels. Then there's this function pd.cut. It's from Pandas. It extends your data sets by this column. So I'm saying look at df underscore diabetes data frame. Creates a new data frame with this age category and add it to df underscore diabetes. Look at the age column in df underscore diabetes, and the bin to use is what you are saying here. Then use these labels. So what's the bin saying? The bin is saying that from 0 to 30, label it as young. From 30 to 60, label it as middle. 60 to infinity, label as old. The same thing for the glucose category, is using this bin and is using this label. The HbA category is using this bin and is using this label. So from 0, from 0 to 5.7 is normal. From 5.7 to 6.4 is medium. From 6.4 to infinity is high. So let's see that. So it's going to substitute the data, creates a new column, and let's see the effect of that on df_diabetes. Look at, we have 3 brand new columns here, which are the columns we've specified for it to create. So for this first guy here, his age is 80 and he has categorized him as old. And this female here is 54 and she's middle age. So like that, that's the beauty of having a tool like this that can easily just group data, label them for you, and as you go on in data analytics, you find this very, very useful. So yeah, once I'm able to achieve this, the next thing I want to do is look at the original data frame. I want to classify, I want to know everybody that is diabetic. Then based on the people that are diabetic, I want to know, classify them or group them by age, by HbA, by glucose level, and all those sort of things. So let's start to do that. I'll create a data frame called diabetic. It's going to derive its data from df_diabetes, and I'm asking it to look specifically at the diabetes column inside the data set, and the value, just give me any row whose value of diabetes is equal to 1. Output it into this variable. So let's see what we have. You can do a df.shape to know the quantity. Yeah, so you have 8,500 rows are diabetic. So next I would like to check and group the create a gender group. I want to know the proportion of male to female using the gender column. I also want to know, based on the age category, creates an age group for me. Glucose category creates a glucose group for me. And HbA category creates something similar. This is the one in here that some of this is deprecated, but it's not an issue at all. Let's look at it to be sure. So you see it's giving me the values. So what do we want to do with all these values? I would like to see visually what they represent, and it has outputted histogram for me. I don't need to reinterpret this. We are very, very familiar already. So based on the titles that I've asked it to give me, see, it's giving me those that are young, middle age, and old categories. So there are more older people that are diabetic than the young, than the less than 30. And then based on the glucose level, high and medium glucose level are more susceptible to diabetes. And then this is very, very evident. You can do the same to look at, repeat the same process for those that are non-diabetic. You just need to change this value to 0. But we're not going to do that because I feel like the video is already too long, but I don't know how to save time than this. So let's perform some statistical calculation on the data frame. So we have the diabetic group already. We'll say create a new data frame called diabetic group and group them by diabetes. Now I want to find the mean values of the data presented in this data frame. So give me the mean age from using the age column. Give me the mean glucose level using this. So create all these variables. The next thing I'm going to do is I'm going to ask it to print me the values from the variables I just created. So there's nothing really, in fact I can just say mean age instead, and I'm going to see what's the value for mean age. But I think if you want to prettify it to look cleaner, let's use this. So print me the mean. These in red are text. Mean age, which is the variable, mean glucose is the variable here, and like that. So let's see. So same as it gave us when we just queried that variable is what is giving us here as well. You can do some other things like finding variance. Instead of writing formulas, you can just find the variance of a particular variable. Let's say age. What's the variance? Round it up. Then I'm saying give me the value here, and that's it. This is the variance. I can do the same thing for standard deviation. I can do the same thing for standard deviation, STD. Sorry, I omitted the E. Yeah, so it says the standard deviation is that. I think we've been able to do a lot of things. We've filtered the data. We have substituted data and label. We've done statistical calculation. So all of these things, I believe by now you are pretty familiar with them. Let me know if you enjoyed this video and ways to improve. If you like it, subscribe and leave a comment. Thank you.